How many different kinds of fertilizers do you need? I mean, there's synthetic, there's compost of various types, fish emulsion, kelp, different kinds of plant meals like alfalfa meal, and they come in all different formulations. And then there's specialty products like bone meal and blood meal. How many of these do you need, both for out in the garden and in containers? That's what I'd like to discuss in this program. I had this question posed in my Facebook group. The soil in my raised bed is a mixture of 1/3 topsoil, 1/3 cow manure compost, 1/3 peat moss with perlite, and worm castings mixed in. I add a slow release 926 all-purpose granular fertilizer, a tablespoon of bone meal, some blood meal, which is a 1400, and then I water that in with some fish emulsion, which is a 511. 14 days later, I start a regular fish emulsion fertilizer every week. I have found another fish emulsion that has an NPK of 0-10-10, and I'm going to start incorporating that later in the life cycle of my plants. Am I doing too much? Is this overkill? That's the question that prompted this program, and I'm going to break it down into two parts. In the first part, I'm going to give you the 30-second answer. In the second part, I'm going to discuss some really important points on fertilizer that are rarely discussed by gardeners. And they're critical to help you understand which fertilizer you should use, how much, and when. And how many different kinds do you need? I know you want to grow great plants, and it seems kind of obvious that if you give them a variety of different foods, they'll grow better. I mean, that's what happens with us humans. You don't want to give them the same food all the time, right? And manufacturers of fertilizer products rely on that. That's why they convince you to buy a lot of different products. So how many do you really need? Well, the short answer is probably only one. You might need a second one in some special situations, but for the most part, all you need is one. To help you understand why you only need one, and to help you select the right one, I'm going to go over 3 key points that you should understand about fertilizer. Ingredients. We're going to look at what's in these fertilizers. The second item I'm going to look at is the release rate. Now, this is something gardeners don't talk about, and it's absolutely critical that you understand what the release rate means. You can't really pick the right product without knowing that. And the third thing I want to look at is the carbon. How much carbon are these fertilizers adding to your soil? And why is carbon even important? Is there such a thing as plant-specific fertilizer? I mean, if you go to the store, you find orchid fertilizer and perennial fertilizer and rose fertilizer and tomato fertilizer, all these different kinds of fertilizers. Well, the reality is that none of those exist. There's no such thing as tomato fertilizer. The ingredients in that product are exactly the same as the African violet fertilizer, as the orchid fertilizer. There is no such thing as plant-specific fertilizer, except in the minds of the marketing people and those customers who buy the products. Let's start with the ingredients in the fertilizer. There's lots of things that go into different fertilizers. Bits of fish, kelp, all kinds of plant meals like alfalfa meal, bone meal, blood meal. And then of course we have the compost, and a lot of that is manure compost. And we have sheep compost and cow compost and horse compost, all these different things. The reality is that what you start with has very little impact on the nutrients that the plants actually get. Let me explain this in more detail. What is the difference between a tomato, and a microbe? Now, I know they look very different, they grow different, and there certainly are chemical differences. But when we drill down and look at the chemistry of those 3 organisms, we find that there are more similarities than differences. They all use proteins, they all use enzymes, sugars, carbohydrates, fats and oils. They all have cells, and those cells have cell walls. The structures are very similar between those cells. On a biochemical basis, there's very little difference between different living organisms. Let me give you just one example. There's a compound called ATP, It's like the little battery that keeps us going. And it's a little battery that's rechargeable. So when we eat things, we take the energy out of that food and we put it in an ATP molecule. When we need energy, we take it back out of the ATP molecule. And then later on, when we eat again, we fill it up again. We recharge that ATP molecule. Every organism on Earth uses ATP to store energy. Absolutely necessary for life. That's how similar these organisms are. What happens when I take a banana peel and put it beside a plant? Does that feed the plant? Well, no, it doesn't. In fact, the plant will starve. The reason is that the banana consists of large molecules, proteins, carbohydrates. These are all huge, huge molecules that plants simply cannot use until microbes come along and digest that banana peel down to its basic elements, the nutrients, the magnesium, nitrogen, phosphorus, potassium, calcium, until it's turned into those simple molecules, those nutrients. Plants can't use it. So it doesn't really matter what I start with. I can take any living organism. Plants can't use it. It has to be digested. It has to be broken down into these nutrients. And only then plants can use it. And all of these starting materials have the same nutrients in them. And that's why the source of the fertilizer doesn't really matter very much. Now, there are people out there that claim some of these fertilizers have magical properties. I hear a lot of people claim that fish fertilizer is fantastic, works better than any other kind. That's simply not true. The science doesn't support that. Vermicompost also has a reputation of being special. It's not. It's no better than any of these other sources. I've looked into this quite a bit, and the only one that I can find that may have some special properties, and that's a may, we don't know for sure yet, and that's kelp. Kelp seems to have some molecules in there that may make plants grow better than other sources. But the science isn't strong enough to get me to go out and buy kelp fertilizer for that reason. Now, the amount of nutrients is important. So if we have two fertilizers and one is a 10-10-10 and the other is a 1-1-1, well, the 10-10-10 has a lot more nutrients in it. So the quantity of nutrients is important. And different products will have different quantity, but the type of nutrients are the same. Now, what ratio do you want? I've discussed this numerous times in other programs. The ratio you really want in a fertilizer is a 3-1-2. More nitrogen, less phosphorus, and potassium kind of halfway between the two. So a 3-1-2 is good, a 6-2-4 is good, a 9-3-6 is good. Those all have the same ratio. So the quantity and the ratio is important. The actual source of the fertilizer is not. The second topic I'd like to look at is the release rate. Probably have never heard that term before applied to fertilizers, but it's absolutely critical. Let me give you a simple example. In the spring, you go out and you plant some tomato plants. They've been in the ground for a week and you go out and look at them and you find the leaves are all yellow and you suspect that they don't have enough nitrogen. So we need to get nitrogen them right away. So you go to the store and you buy yourself some good manure compost and you spread it around your garden. What's going to happen? Well, not much. You see, the problem is that compost is mostly made up of these large molecules. There's very little nitrogen that's available to your plants today. Compost is a slow release product. It's going to feed the garden for years, but it does very little for today. So the plants will keep suffering even though you just fertilized them. Each type of fertilizer has a different release rate. It's a measure of how quickly does this material break down and turn into the nutrients that plants need. That's that nitrogen, phosphorus, potassium, magnesium, and so on. Think back to the example I gave you about the banana peel. Right? A banana peel sitting on the ground doesn't release nutrients. It's all large molecules. Until that thing rots down to the point where we can't recognize it, it doesn't feed plants. So let's have a look at some of these release rates. Here's a table I found in a scientific journal that gives us some relative values. If we look at bone meal, and the last column gives us the relative availability, it's slow. Bone meal breaks down very, very slowly. If we go down that list, cocoa shells, that's also slow. Compost, it's also slow. Cottonseed meal, That's a slow medium. Dried blood or blood meal, that's a medium to rapid. I know from looking up blood meal that it decomposes pretty quickly and the nitrogen in it is made available in somewhere between 2 and 4 months. How about fish emulsion? That's the liquid form of fish, and it's quite rapid. And the reason for that is that fish has already been processed and partially turned into a liquid, so the nutrients are readily available. But if we now get real fish, so either as a dry meal or a scrap fish, these things are going to be slow because they have to decompose before plants can use them. Now this table is very interesting, but it gives us relative values, slow, fast. Well, what is slow? Are we talking days, weeks, months, years? So if you do a little more digging, you can actually get real data on some of these. Here's a table I found of some common fertilizers. Poultry floor litter. That's basically chicken manure. The first year, 50% of it is released. The second year, another 15%. Third year, 8%. And fourth year, 3%. Dairy manure. Numbers are somewhat similar. 35% the first year, and then a little bit in each subsequent year. Composted sewage sludge. Only 10% is available the first year. And I think the reason for that is that it hasn't been decomposed very much by the time you buy it. And then you get a bit more each subsequent year. So why is this important? Well, if I put compost in my garden, I want to know how much is made available for plants, both in the next couple of weeks and over the next month, over the growing season, and then how much is left for next year and the following year and so on. In general, compost lasts about 5 years. A large part of that is released the first year, but it takes a whole summer for that to happen. So if I'm growing something and I want to feed the plants now, like my newly planted tomato example, or perhaps this is a house plant that's growing in a pot and I want to feed it today so it grows. These organic materials are not the best choice because they take time to decompose. Synthetic fertilizer has a release time of almost instantaneous. As soon as it dissolves in water, it's available for plants. And that's one of the big advantages of synthetic fertilizer. So if we go back to my tomato example, it's sitting in the ground, it's starving, it needs nitrogen. I'm going to use synthetic fertilizer. I know that if I apply it now, within minutes and an hour, the plant has access to nitrogen. Now the downside to synthetic fertilizer is that it doesn't last very long. So in a month from now, that nitrogen is all gone. Whereas if I put in compost, I'm going to be feeding my plants for years to come. That's why the release date is so critical. If you're doing long-term soil building, long-term fertilizing, organic material is great. But in situations where you need quick feed, like houseplants and those bedding plants that you plant in the early spring and you want them to grow and flower right away, that's where synthetic is much better. All right, so how do you find out what the release date is of these various products? Well, it turns out that because gardeners aren't asking that question, manufacturers aren't giving you the answers. I looked at several bags of organic material, and not one of them gave you the release date. Sometimes you can get a bit of a sense of the release date because they tell you how often to apply it. So blood meal, for instance, they tell you to put it on every 2 or 3 weeks because it releases quickly. And to be quite honest, what I found was that the recommended times for applying these materials didn't really match their release dates. The third topic I'd like to look at is carbon. How much carbon do these various fertilizers supply? And why is it important? I know a lot of you know that if we add organic material to soil, it improves the quality of the soil. It builds better soil. It increases the number of microbes in that soil. That story is only partially true. So if I take something like compost and I put it in the soil, that compost is a great food source for microbes. As microbes slowly decompose it, they release nutrients, but they also improve the quality of my soil. It's the microbes that are building the good soil, not really the compost. The reason this happens is that the original compost had a lot of carbon in it. And I'm using the word carbon as kind of a short form reference to the fact that it has a lot of organic material, a lot of organic chemicals in there, proteins, carbohydrates, and so on. I prefer to call that carbon because the term organic material is confusing because there's certified organic, and then there are compounds that the chemists refer to as organic. And that gets a little muddy if you're not real clear on the term. So let's talk about carbon. So we want to add more carbon to soil. That carbon feeds the microbes, and in turn, we get better soil. When we want to build soil long term, it's important to have more of this carbon material. So the soil in your garden is a good example. We want to build that up. We want to make it better. On the other hand, your potted house plants are in a soilless mix. We're not interested in growing microbes there, and we're not interested in building soil there because we don't even have any soil. So adding carbon in that situation isn't important, but out in the garden, in real soil, it's critical. Now, it turns out that when we look at these organic fertilizers, we can split them into two categories, the solid materials and the liquid materials. And those behave quite differently and give you different value in the garden. So here's a list of some of the solid fertilizers, things like compost, manure, various plant meals, and leaf mold. These are all solid materials because you can pick them up and hold them in your hand. They're actually solid. Now, we also have a number of liquid fertilizers. And in this category, we include things like seaweed extract, fish emulsion, your various teas, things like weed tea and compost tea. And I've also included blood meal here. Now, blood meal is actually a solid, but it behaves a little more like a liquid. So what's the difference between solid and liquid? Well, it turns out that the solid materials contain a lot of carbon, and the liquids contain very little. So if I'm looking for a product to increase microbes and build soil structure, I want to focus on the solid ones. The liquid ones aren't going to do the job for me. A little while ago, I did an analysis on my blog, gardenmyths.com. The article was called Fish Emulsion versus Compost. And I looked at the differences and tried to figure out which one is better for the garden. If you want to know the details of the calculation, I'll put a link to the article in the description below. So as an example, I took a Neptune product, 1 pint of it, and it's a 2-4-1 emulsion fish fertilizer. If you follow the instructions and apply it to your garden, you will add 14 grams of solid material for every square meter. Now, if I take compost and apply that as a 1-inch layer, I'll end up adding 10 kilograms of solid material per square meter. The compost is adding 700 times as much carbon as the fish emulsion. And remember, this carbon is what feeds the microbes. Both compost and fish emulsion are considered organic fertilizers. The manufacturers tell you they both feed microbes, and that's true. In one case, in the case of fish emulsion, you're adding a tiny little speck on a whole square meter. But with compost, we're adding 10 kilograms per square meter. More carbon means more microbes, which means better soil building. What about synthetic fertilizers? How much carbon do they have? Well, they have pretty much zero. Synthetic fertilizers are designed to release the nutrients plants want very quickly. They're not designed for long-term soil building. So as far as soil building goes, they're even worse than the liquid fertilizers. So what does the amount of carbon mean to you? Well, you really have to understand your goals. If your goal is long-term soil building, buy a solid material. Don't buy one of these liquid fertilizers. All right, let's get back to the original question. How many different kinds of fertilizers do you need? Well, to answer that, you need to know what your goal is. If I'm interested in feeding my plants and giving them the nutrients, I only need one. If I can get a fertilizer with a ratio of 3:1:2, that will provide the nutrients my plants need. Now, if I have a deficiency, and I know I have a deficiency of one of those nutrients, then I also want to add it. So I might want a second fertilizer. But remember, the only way to know if you have a deficiency is to actually get a soil test done. You can't look at your plants and determine what your deficiency is. Now, a lot of people tell you to do that all over the internet, but that information is wrong. You cannot look at a plant and tell what your deficiency is. If your plants aren't growing well, you have to get the soil tested to figure out what is missing and then add that nutrient. And then in addition to that, you want a general purpose fertilizer in the ratio 3:1:2. Is there value in adding different sources of fertilizer like vermicompost and fish emulsion along with your compost? No, there isn't. I know the manufacturers will make you think there's a benefit, and many gardeners online will tell you that these have special properties, so you need a bit of both. But the reality is that you don't. When all of these products decompose and release their nutrients, as far as the plant is concerned, they're identical. The nitrogen from vermicompost and from fish emulsion is identical. The potassium is identical. The phosphate is identical. Plants don't care where it came from. They only care that the right amount of nitrogen is in the soil. So what kind of fertilizers do I recommend? For short-term feeding, like house plants and containers outside, I prefer synthetic fertilizer. I know what I'm adding. I know that as soon as I add it, it's available to plants. When I add something like compost or vermicompost to a potted plant, I don't know when the nutrients are going to be released. I might have added that 2 weeks ago and my plants are starving. Now, if I'm out in the garden and I have real soil, there I want to build for a long-term structure. If I've made a new garden, I might add some synthetic fertilizer to feed my plants this year. But I also add compost for long-term feeding. And which organic fertilizer is best? Well, in my opinion, the one that's the least expensive for the nutrients you get is the best option. In most cases, that means it's been trucked around the country the least. You know that farm down the street that makes cow manure? That's a good choice because it's inexpensive. It hasn't been trucked, and remember, trucking harms the environment. It's probably less expensive, and it's as good as any of the fancy stuff you can buy in bags. If you just need small amounts, it's okay to buy these things in bags, but figure out the cost for the nutrients you're actually getting and buy that product. Don't be swayed by the fancy labels. It's all pretty much the same thing. Now, if you're not very familiar with fertilizers, this video right here will be of interest to you. It explains what the NPK really is. If you think a 10-10-10 is 10% of each nutrient, you better watch that video because that's not right. And if you think a balanced fertilizer is a good choice, this video over here explains why a 10-10-10 is almost never the right choice. Happy gardening.